Hello, welcome to another Stat 432 video. No musical intro on this one because I know I'm going to ramble. We need to get right into it. I have my buddy Grogu with me today. Maybe he'll help us out if I get stuck, which could happen in this video because I'm going to try to code some things that I normally don't code to illustrate a few concepts. So the goal of this video is to basically show you some ways to sort of repeatedly run functions, or should I say applying them to a bunch of different elements of a list or a vector, which is something that'll be sort of very useful for working with Bootstrap, cross-validation, some other things. But this video is more about coding, less about those things. So let's jump into it. I'm working from no notes here. I'm gonna try to do this on the fly so that I can sort of talk through my process and hopefully encounter a few errors that I have to dig myself out of, so I can show you that process as well. But let's jump into it. So first thing I'm gonna do is I'm gonna make some data. Nothing interesting. So I'm gonna make in particular a vector. So I'm gonna call this some vector. rnorm. Let's do like 200 observations. So all this is, it's some data, right? And it's stored in a vector. All right. So what we're gonna do, I guess I should say we, it's me and Grogu. What we're gonna do is something really simple. I want to square each of these numbers. And what I'm gonna do is I'm gonna do it 4 different ways, from least appropriate within the R programming language to the most appropriate within the R programming language. So they're all going to be correct in that they all create a vector of length 200 that includes these elements but squared, but they're going to be wrong, quote unquote, wrong in various ways, be it they're error prone when you write the code or slow. So we're going to start with the worst possible thing here, which is a for loop. Okay, so 2 quick comments here. One is sometimes you'll hear the phrase R is slow. Without going into the details, I disagree. What I think would be more appropriate to say is that R is an interpreted language, and it has whatever speed penalties most interpreted languages have. So yes, if you write the same program in pure R language versus pure C++, and both programmers did it like to the best of their abilities in those language, yeah, the C++ program probably going to run faster. But they're 2 different languages for 2 different reasons, and increasingly, our functions are written with something like C++ under the hood. But you know, if you have compiled code, it's going to run faster. That's just part of it. So I think that the generic statement that R is slow is misunderstood. R is slow in the same way that Python is slow, because Python is also an interpreted languages, and also increasingly depends on C and C++ and other more performant code under the hood. So I think that's a bad statement. The other statement that gets thrown a lot around is you should not use for loops in R, which I agree with, but that doesn't mean you should never write a for loop in R. Sometimes it is appropriate, especially when you need to sort of iterate in a way where the next iteration depends on the previous one. You're kind of out of luck there, and you got to write a for loop. But taken together, if you write for loops in some bad ways, you're going to end up with some really slow code. That's what I'm going to attempt to do right here. Okay, so ultimately, I want some results. And then what I'm going to do is I'm going to do for I in 1, 2, 200 is my sample size here. Okay, so what I'm going to do, sorry, this is hard for me because I don't ever do it this way. Res1 is equal to res1 comma this, the ith element of it squared. So this would be called, so here I'm initializing an empty vector, and here I'm growing it. So let's run this. Let's look at the results. Those are all positive numbers, so they're probably correct, but we'll sort of check that in a little bit. Okay, this is correct in that I do believe it gave the right answer, but it's bad code. So I'll point to two main issues here. One is that the way we wrote this is highly error prone. So there are a bunch of different ways we could do this, but for example, I'll make one simple change that isn't necessarily the absolute correct way to do it, but is a much safer way of doing things. So if instead of directly specifying that 200, I said length of sort of the vector that we're kind of iterating with respect to, this is safer, it's less error prone. But the bigger issue here, that's just sort of a preventing human input error. The bigger issue is this growing the vector issue. So if you say we're coming from programming C, this probably looks very normal to you. But the way those two languages deal with memory under the hood is very different. And without getting into the details of it, this is a trap in R. You don't want to do this because, long story short, you start with a null vector and then you're appending to it. But when you're doing that, you're creating a bunch of different copies of the vector instead of modifying it in place. So this is slow. I mean, it looked really fast because it was not a lot of observations and not a lot of iteration. But if you did this on a bigger vector and more times, it would be slow compared to the things I'm going to show you next. Okay. So even though this situation would never actually require a for loop, which we'll show later, if we were going to do a for loop here, there's better ways to do it. So now let's try that. So this is I won't say good, I'll say decent. Decent way to write a for loop in R. Okay, so step one, we don't initialize a null vector. We pre-allocate the vector of length we're going to need. So this time, I'm going to initialize a numeric vector of length equal to the length of this vector. So just to show you that real quick, notice this vector is already the appropriate length. So then we're going to write a for loop. So for I in seek long this vector. So just to show you what this does real quick. Ooh, that's really nice. Even better than this. And then what we'll do is res to. So we'll just modify the individual elements of the resulting vector instead of appending to the end. That is just better for how R manages memory. And then, so we just got to do this right here. Okay, let's run that. Let's look at the result. And let's just quickly verify something. The two results are the same. So both of these are correct and that they get the right answer, but we prefer this one because it's safer and it's faster. Okay. Now, I want to go one step further and just not use a loop. So what I want to do, if we look at the original vector, said another way, what we're trying to do is imagine there was this, actually, I'll write it. Let's say we had a function called square. And what it does is it takes its argument and it returns the square of it. So for example, if I square the value 3, I get 9. All right, so what I really want to do is take this function and run it with each individual element here passed as the argument to this function. Set a little closer to what it is in code. I want to apply this function to each element of this vector. Turns out, in R, there is a suite of functions that we sort of casually refer to as the apply functions. There are many. Apply, sapply, lapply, mapply, tapply. I'm probably forgetting one. But so I want to simplify things, and we're going to talk specifically about lapply and sapply's relationship to lapply. So let's start with lapply. So, okay, and lapply, that L, think list, because lapply is always going to return a list, and then I'll explain sapply later. So lapply. So notice there's this little thing in RStudio called a snippet. So what this does is says, hey, this is sort of like the structure we're expecting for these lapply functions. So first it wants a list. List here can be either a list or a vector. So I'm going to put the vector that we care about here, and then this is the function that we care about, which is this one here. So what this is going to do, it's going to run the square function with this passed to it. Then it's going to run the square function with this passed to it. Then it's going to run the square function with this passed to it, and so on and so forth. Which sounds like what we want. But when we do that, we see that what it returns is a list of length 200. It has all the right values. It's just not in the data structure we would really expect, right? So having a list where each element is a vector of length 1 seems kind of weird. What we'd really like here is a vector of length 200. So that's where we make one little change and say use sapply instead of lapply. So lapply, it's gonna return a list. The S in sapply stands for simplify. So what it is basically doing, it's running lapply, but if it sees there's a really easy way to simplify the resultant data structure, it'll do it. So some people would be of the opinion that that's not great because depending on the inputs, if you don't know what they are, you don't know what the output is. And we'll see a system that sort of has some checks and balances for this later on, but that's what it does. Okay, so let's call this res_3 equals this. And just for a sanity check, identical our previous result to this one, they are indeed the same. Okay, except, this is great. This is good code. I like this code. Except I could have actually done this in one line. Let me show you how. Those should be regular. Okay, so this will do the same thing. We can check it actually. It did. Okay, so I'm actually going to put this down here. This example uses an apply function. So what I did here was instead of defining a function in my global environment and giving it a name, I said, well, I'm just going to write the function right here and not even give it a name. So this is what's called an anonymous function because we've written a function, but we haven't given it a name. But we don't need to give it a name because it's immediately going to be applied to each element of this vector and does what it wants, and we don't need it for anything else, so there was no need to define it and give it a name. I just wanted to show you this first, because I think it's startling to see the anonymous function before you see it written like this. Okay, so that's the apply function. I'm going to come back and do some detail on the apply functions in a second, but I want to go one step further. Okay, so we've seen a bad for loop. We've seen a decent for loop. We've seen an apply function. Now I want to do it the best way. Hopefully, if you've been following along in this class, you've been screaming at your computer, Dave, what are you doing? These are the silliest ways to do this. I agree. That's how you do it. Oh, actually, so I would say this is the way. Right, Grogu? Right. Okay, so this is vectorized code, right? So it's already doing things vector by vector, so we don't need to do any of this stuff. So I think when you realize this, that a lot of these functions in R are vectorized, life gets a lot easier, right? So we don't need to do this C programming nonsense that's hard to write and hard to look at, hard to understand what's going on. We can just do this. Oh, and just in case you didn't believe me, all the same stuff. Okay, cool. Right, so that's 4 ways of doing the same thing from how you should, from a way that is correct but you really shouldn't do, all the way down to what I would call is the most idiomatic R you could possibly do. This is how our programmers do that task we set out to do. Okay, so, right, so I think now I want to sort of talk a little bit more about the apply functions. So what I want to do is use the apply functions, in particular lapply and or sapply, actually a little bit of both, to do some bootstrapping. So let's do that. I'm not going to focus on the bootstrap of it all, although I will talk about it a little bit more about the coding aspect. So let's do this. I'm just going to import some data real quick, as I'm going to call this penguin. Okay, so this is a data set about some physical characteristics of penguins. So, and here's what we could do. We could look at something like this. We could do the correlation between this variable here and this variable here. So we're looking, so what we have here is the correlation between the bill length, so like how long their nose is, versus its depth. It's one of these dimensions. I don't know. But it's a relationship between some of the dimensions of these penguins, bills, beaks, whatever you call it. I'm not an animal biologist. Right. So we find this correlation. But let's say we wanted to create a bootstrap confidence interval for that, right? So we're going to need to do some things, right? We're going to need to generate bootstrap resamples, that is sort of reshuffles of our data, apply this statistic to those data sets, and then maybe do some summary stuff to it. Okay, so let's think about that. So I'm gonna try to break this process down and then maybe come back and summarize it very quickly. But so what I want to do is first I want to create all of the bootstrap resamples. So what I want is a list where each element of the list is a bootstrap resample of this data. So first thing I'm going to do is I'm going to say boot resamping is a function of the data. Actually, I don't even need it. This isn't even necessarily specific to penguins. So what I'm going to do, I'm going to grab the length of that data. Then I'm going to sample the numbers 1 through that length. I want full size and replace will be true, because that's how Bootstrap works. So I'll call this the boot index, I think. And then what I'll do is I'll take my data and I will rearrange it according to that, and that's what we'll return. I'll make that explicit. Okay, so before you start iterating, you should generally check that what you have works. Seems to work. Every time I run it, I get a bootstrap resample. Okay, so now what I want to do is I want to slam all of that into a list together. So actually, the lapply functions won't necessarily help me here, because really, I don't want to apply a function to a bunch of different values or a bunch of different elements of a list. All I really want to do is repeatedly run this code and store the results in a list, right? Okay, so to do that, there's this handy function called the replicate function. So let's say I want to do 1,000 bootstrap replicates. This thing I've been running is the expression I want to repeat, and I'm going to run this real quick. Notice that this doesn't look like a list. It's trying to do something funny. It's trying to make it in like a, I don't know if this is a matrix or a data frame, but I don't like that. So what it's doing is under the hood, it's trying to simplify the data structure. I don't want it to do that. So I'll call this penguin resam. Okay, and if we look at this now, I regret outputting this because it's going to take a minute. But see how this is a list where each element is a data frame. Cool. That's just going to have to run for a little bit. Okay. So what I want to do now is calculate the relevant statistic, that is the correlation between the two variables, on each of these data sets. Okay. So while this is running, I'm going to run a function to do that. Do I need a function? Yeah. I don't know what to call this function. Calc boot core. Or no, we'll just call it calculate core. Oh gosh, my computer's not liking this. Okay, so it'll be a function of the data. Okay, and so, we'll call this calc core penguin. So this function is only going to work on the penguin's data set because I'm going to use some of the variable names. Okay, so we're going to have x is going to be the data $, this variable, if I can copy it. Oh gosh. And then y is going to be the data $, that other variable. Nope. I want depth. No, did I not copy it? Okay, well anyway, this should be depth, I think. Depth. Okay, and then lastly, we will return, what is it? The correlation between x and y. I'm gonna let this run for a second because it's slowing down everything. It's almost done. Oh, okay, good, okay. So let's test our little function here. So I'm just gonna test it on the original data set. Cool, that works. All right, so again, remember, this stores a list where each element is a bootstrap resample. So now what I can do, bring out lapply, say to this list. So it's gonna, each time what it's gonna do, it's gonna run this function, it's gonna run it here, it's gonna run it here, it's gonna run it here, and so on and so forth. So if we run that, there we go. But right away we can kind of see, wait a second now, that kind of looks like a list, but given that each element of the list is a vector of length 1, I probably just want a vector, so we can do sapply. So these would be the bootstrap replicates. And then from here, you could use these to go on to make a confidence interval. I know what confidence intervals are. Okay, so yeah. So this example here, we had our data in a data frame. I want to note that this intermediate step of storing all the data frames is not necessarily, you don't have to do that. So what we could do here is something like this. So we could boot resamp the penguin data, right? And then we could immediately apply this, or sorry, I want to say run this function on that data. So we see now, check this out. So if I keep doing this, each time I'm generating a new bootstrap replicate. So what I could do here is use this replicate function. Let's do it like 100 times just to make it quick. And because simplify is true here, it does, and it simplifies it down to a vector. This is another way to get the bootstrap replicates. The other thing I want to say real quick here is that I think sometimes in other examples, for more basic examples, sometimes the data might not even be stored in a data frame. It might be in a vector. So just note that's the case. And the resampling would be done a little bit differently. You wouldn't be reshuffling rows of a data frame. You'd just be reshuffling elements of a vector, which is a little bit easier. Right. Okay. So, right, that's a little bit about apply and sapply. I kind of don't want to say too much more about it because I think if I say more, it'll confuse it. But so basically, long story short, lapply takes a function and runs it for each element of a list or a vector, and it outputs a list. That's all it is, and there's a lot of times you can use that in place of a for loop. Okay, so the last thing I want to mention real quick, in the previous two videos, I think if you're watching these in the right sequence, I used a function called map from the purrr package. So purrr is a part of the Tidyverse. And the Tidyverse is, I believe in the description of the creators, an opinionated set of packages for data analysis. I'm paraphrasing, but I do know that the word opinionated appears in there because they have some very strong feelings about the way functions should work. So what I mean by that is the tidyverse would not contain functions like sapply, where it tries to modify the data structure it returns if it can. Functions in the tidyverse will always return the data type that you expect. I'm simplifying that a little bit, and I'm overstating it a little bit, but it is important to realize. But so what I want to do is I want to compare these two approaches. That is using purrr map and using lapply. Here's the long story short. They're exactly the same. That's not true, but for all intents and purposes, they kind of are. So, for example, let's say remember what's stored in here is that big nasty list of all the data frames. Here, let's do this. Not outputting the whole thing, but we see it's got a bunch of data frames, right? So in the last example, we did this to get our answer. So I want to do it with purrr now. So with purrr, I'm literally going to insert the same arguments. Look at that. Actually, let's do this. Those are pretty much the same thing, right? Okay, cool. So in the lapply world, to get the vector, we changed from lapply to sapply. And it seems like it worked, but again, in the background, R is like guessing. I'm not using the word guessing correctly there, but ultimately it's making sort of a decision that you can't always anticipate if it's going to return like a matrix or a list or a vector. With purrr map, this function always returns a list. If you want a vector, you need to use purrr underscore. And then, so for example, if you wanted to return a character vector, use map underscore chr for character. If you want numeric, non-integer, double. So this is what we want. We get the same answer as sapply. Cool. So that's kind of all I want to say about purrr. Basically, purrr map is the same as lapply. And then if you want an equivalent to sapply, you would need to use one of these more specific map functions that sort of basically specifies the type of vector that's being returned. That's the long story short with that. Purrr as a package has a lot more functionality and can do a whole lot of functional programming type stuff. But for our purposes, that's all we'll need. I want to say one more thing though. Because I think I used this in some of the other videos. So way back up here, we were talking about anonymous functions. I haven't done this in a while, so I might screw it up. But purrr has its own syntax for doing anonymous functions. So I'm going to do an example, not with the bootstrap, but with... Actually, I think I'll do two more examples. I'm gonna redo this example with purrr real quick. So let's do that. Well, actually, I don't want to rerun that because it's random. Okay, so I want to square that with purrr again. So a weird thing to do, but I want to try something. What, db, I can't type. Okay, there it is. All right, so we're mapping to this vector or list or potentially other data structures, a function. So what that function is going to be is I'm going to square it. So does that do it? Yeah. Okay. So this is some kind of gnarly syntax. So essentially, this is a way for functions in this purrr package. I forget if this applies to the tidyverse in general or not, but at least to purrr, to make anonymous functions. So the tilde here basically says, hey, we're making an anonymous function. And that anonymous function, this would be the name of the argument, and you just use it immediately and then square it. So just to be clear here, this is the same as if we were to do this function x. That's the same. The other thing that would be the same, I think I deleted it, but it should still be in my environment. Argument f is missing. Is this not? Really? Oh, I'm using the wrong map function. That's a whole different function. There we go. So these three things are all the same. So yeah, let me actually. I'm gonna do one more example. So I'm gonna do an example of Bootstrap where you're just bootstrapping a vector. So we'll create some new data and we'll say something like this. N is 200 and the rate is, I don't know, I'm just making this up. Okay, so we have some data. Who cares what it is? Oops. Whatever. So let's say I want to bootstrap a median here, right? So I'm going to try to do this as easy as possible in my mind. So, or no, I'm going to do it as safely as possible. Now I'm just going to do it. So the first thing I want to do is make sure I can bootstrap resample this data. So because it's already a vector, my life is a little bit easier, right? So if I just say sample the data, replace equals true, that's already doing it. That's already creating a bootstrap resample. And so I think what I said was I wanted to use the median. So median like that. Something like that. So already I'm making bootstrap replicates. It's that easy. So in this case, I don't need purrr. I don't need lapply. Those are really nice for, you know, working with some more complicated structures and whatnot. I can just jump right to replicate here. So let's say I wanted, I don't know, 1,000 bootstrap replicates. There it is. Done. So this code is maybe a little harder to read because it's doing the bootstrap resampling, the calculation of the replicate, and doing it a bunch of times all in one line. But this is a totally valid way to do this. Because the lapply and things, they can be used here, but the sort of difference is that lapply, you're applying a function to a bunch of different inputs. Here, the input is basically always the same, unless you were to be intermediately storing the bootstrap resamples like we did in this example up here. Okay, so that was kind of a lot. Grogu, any thoughts? Okay. Grogu's got nothing to say. He's a little shy. Okay, so kind of wrapping up a little bit. So hopefully you have a better understanding of a few things in R. You have a better understanding of a for loop and how to write them correctly if you're going to write them. But more importantly, you have an understanding that you should avoid them and do it a more R way. Recall, this is the way. Vectorize when possible. Next, hopefully you have a better understanding of the apply functions, in particular lapply and sapply. There are other ones, but we're just dealing with those here. And then hopefully you also now understand this replicate function, or at least that it exists, and you can start trying it out. Very useful function in R. And then lastly, hopefully you see the correspondence between the applies and the functions from purrr, as I've sort of interchangeably used both those throughout the semester, but now we've sort of unified and you can use whichever one you want. Okay, so that was kind of a lot of me rambling, but hopefully that gets you thinking about these things and gets you the coding information you need to complete the bootstrapping that we're doing this week. Okay, so if you made it to the end of the video, good job, and I will see you in the next one.